So as we say that therefore the torque along to the point A must be equals to m1 times r1 square times the angular accelerations. This is the equation number 72 for our fourth equation here. Now we say that similarly for the particle B. Now let us go and focus for the point B, which is similar on how we demonstrated the force like that at the point B, at the point A. Now the force at the point B can be expressed using the Newton second law, ambapo anasema at the point B force B must be equals to m2 times a2, where this m2 represents the mass of the particle 2, and this a2 here represents the acceleration of the particle 2, which is located at the point B. But after this one here, let us represent the angular velocity, the acceleration in terms of the angular acceleration. And we know that in terms of the angular acceleration, this acceleration must be equals to r1 we multiply by the angular acceleration. This is the formula of obtaining the angular, the acceleration 2. Now we should substitute that instead of writing a2, now we could place r2 times the constant angular accelerations as we observe here. So after this one, we should conclude by saying that FB must be equals the force along to the point B must be equals to mass 2 times mass 2 times r2 times this angular accelerations. So hence the moment of force or torque on the particle B is like this one. Now after this one here, let us, after obtaining the force which is equal, force along to the point B, which is equal to mass 2 times r2 times the angular acceleration. Now we say that the torque along to the point B must be equals to the force along to the point B, then we multiply it by r2, the distance that exactly from the axis of rotation or from the center to the particle to the particle B. This is represented by r2 here. So after this one here, therefore we could substitute FB as the subject. Kwa hiyo tutakuwa tuweza kusubstitute FB here ambapo atakuwa ni sawa na nini? As we know that the FB we try to demonstrate as the equation number 73. Now we are supposed to substitute which is equal to m2 r2 angular accelerations. Now if we substitute, we could get that m2 times r2 square times this angular acceleration represent the torque at the point B. Kwa ukiambiwa sasa kwamba je, tunapataje torque at the point B? Utamwambia torque at the point B is similar with that at the point A, lakini allocation of the particles those zinaseparatisha. Kwa the torque along to the point B must be equal to m2 times r2 square, then we times by the angular acceleration. This could be our 74 equation for our fourth topic here. So finally, the total moment of the force for the whole boat about an axis PO is equal to this one. Kwa tunaweza kusema sasa we could conclude by saying that finally this total moment of force for the whole body about the axis PO is equal to this one. Kwa hiyo tuweze kupata sasa torque kwa ujumla, the whole the torque for the whole rigged body atakuwa ni sawa na kumchukua yule torque along to the particle A, then we add by the torque along to the particle B here. If we have many particles, now we should say that the torque of the total moment of the force for the whole body. The torque for the whole body must be equals to the torque along to the point A then we add by the torque along to the point B. We add by dash until to the torque along to the NC terms as we try to demonstrate here. But after this one, let us substitute the mass. Let us substitute the torque, the formula of the torque with respect to the equation that we try to demonstrate on 74 and also 73. If we substitute, we could say that the torque must be equals to m1 r1 square, then times the angular acceleration we add by m2 times the r2 square, we times it by the angular acceleration, then we add by m3 if we have 3 particles, or if we have many particles allocated for the body. Now we could say until to the AC terms. Now if we simplify this one, we see that this angular acceleration is a constant for every particles. If it is constant, now we were supposed to factor it out. Kwa tunachokufanya pale tutamfactor huyu angular acceleration nje kwa sababu ni anafanana, which simplifies to this one. This must be that if we factor out, tutaweza represent as torque must be equals to m1 to bracket m1 times r1 square, then we add by m2 times r2 square, we add by m3 times r3 square, then we add by dash then the NC terms of the mass of the particles times Rn square, then we multiply by the angular acceleration. This might be the equation number 75 for our first topic here. So as we try to observe, now we can say that the definition of this m1 r1 square, we add by m2 r2 square, then m3 r3 square until to the nth terms of mn of m times r square. Now we could say that this must represent the moment of inertia for the whole body, kwa sababu tunajua moment of inertia for the individual bodies is equal to mr square, lakini sasa for the whole tunamwambia kwamba hawa wote hawa ambao tunawaona hawa ambao tumeweka kwenye mabano ni sawa na ile moment of inertia ambayo ita express for the whole body. So we could say that this I is the moment of inertia of the body about axis through the point O. This might be represented as this one. But in equation number 4 times number 4, in our equation number 75 for our first topic here, the moment of force or the moment of force or torque of the whole body about an axis through the O can be expressed by this one. Kwa sasa tukirudi kwenye ile equation ya 75 as we tried to see our equation number 75, we say that this which are found inside the bracket is equal to I. Now we could say that this torque must be equals to I times the angular accelerations. Kwa yule torque atakuwa ni sawa na I times the angular accelerations. But we know that this angular acceleration represents the rate of change of W, or the rate of change of the angular velocity. Kwa hiyo tunamwambia sasa kumbe torque anaweza kawa either ni sawa na huyu moment of inertia for the whole body, then we multiply it by the angular acceleration, which must be equal to I times the rate of change of the angular acceleration. This might be the equation number 76 for our first topic. So there are some tasks here you'll be asked, my lovely student, is that can you prove that the torque for the whole body might be equals to I times the angular acceleration? Ndio swali ambao unaweza ukakutana nalo kwenye mitihani yako. So by saying that, my dear student, this is the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.